Okay, here's a question where they're asking to what is the redox reaction most likely that'll happen with this beaker. So they have a gold ring, gold, and it's solid, so it'll be Au solid. I'm looking for that. Beaker hydrochloric acid, it's an acid, so there's got to be water. And it's hydrochloric acid, which is one of the top dogs, and so I'll have hydrogen ions, and it's hydrochloric, which is HCl, so I'll also have Cl minus ions in there somewhere. So here's the four species. Gold's on the right side, so it's an Ra. Water is on both sides, so it's an Ra and an OA. Hydrogen, it's on the left a ton. I think it's only on the left. I'm not positive, but maybe there's some where it's on the right too. But anyway, it's typically on the left, so it's an OA. And Cl minus, I'm not sure. Let me look for that one. Cl minus, oh, it's on the right-hand side. So Cl minus is on the right-hand side, so it's an Ra. Now, when I took a look at them, it looks like the furthest one down on this side is water. So I just copied that reaction, the water reaction, the O2. So this one here is my SRA. And then the one furthest up on the left appeared to be this one right there. I think there's one more down below. Yeah, water's down below there, but the hydrogen ion looks like it is the strongest oxidizing agent. And that's why I wrote that one there. So SOA. So the hydrogen ion is my SOA, and the water is my SRA. Okay, so now my SOA is this. I'm going to write that equation down. So 2H plus 2 electrons is in equilibrium with hydrogen gas. That's my SOA reaction, gas. And then my SRA, I got to flip it around, right? So I put 2H2O on this side, is in equilibrium with O2 plus 4 hydrogen ions plus 4 electrons. Okay, good. I'm just going to get rid of this stuff just in case I need room. Oh, maybe I need those numbers though, eh? Maybe I'll just move it down. Okay, so take this stuff, move it down just a touch. Okay, now let's add these things up. Oh, I got to make sure electrons balance. I got 4 here, only 2 there. So I'm going to take this whole thing and times it by 2. So when I write my whole thing, I'll have 4 electrons on the left and I'll have 4 electrons on the right, so they'll cancel. So now I just have to multiply everything inside here by 2, so that'll be 4 H pluses. Electrons cancel, and 2 waters. Notice I don't have to multiply this one by 2 because it already has 4 electrons. Is in equilibrium with, on this side I have 2 waters plus O2 plus 4. Well, that's not a water, that's hydrogen gas. What am I talking about? Anyway, it'll be 2 hydrogen gases. Gee, that would have been bad. Let's just erase that, just so I don't mess that up. And I'll fix that up there too. So 2 hydrogen gases, and so down here this is 2 hydrogen gas. Okay, O2 plus 4H plus and 4 electrons, but the electrons cancel. Now one interesting thing that happens here is that I have 4H plus on this side and I have 4H plus on this side. Well, if I can cancel the electrons out, because they're identical, here this 4H pluses will cancel with those 4H pluses. So really, my net reaction is only 2H2O is in equilibrium with 2 hydrogen gas plus O2. I like to just confirm to make sure that everything's still balanced. 4 hydrogens, 2 oxygens, 4 hydrogens, 2 oxygens, it is. Now, probably should do our spontaneity as well. This first reaction has 0.00 as its, or I guess all of the other electrode potentials are really referred to hydrogen as the base one. So it's 0, 0, and then this one I had to flip around so that becomes a negative, negative 1.23. If I add those together, I get negative 1.23. Since it's negative, that means that it's non-spontaneous. In other words, if you drop your gold ring in hydrochloric acid, it won't do anything. I probably wouldn't advise it, although maybe it might clean it. But according to the redox reactions we have here, nothing's going to happen. The reaction will be non-spontaneous.